Okay. We will start to Cabri today, hopefully, inshallah. Let's see. Okay. One last confirmation that if you hear me.
We can hear you.
Okay, thank you so much. And I'll start screen sharing as soon as I have the projector on. I will log out and log in again to enable my screen share. Great. Um, right now, so I have the Cabri Express on, so you can use the Cabri Express on your computer too. And it runs on your browser. What you do is, let me show you. You can just like search for Cabri Express, and then probably the first link, Cabri Cloud, is the app that I ran. Loading. This is not still yet as powerful as the Cabri 3D, the original software, but they are not upgrading that, so that's the reason we're switching to this one, but hopefully that's going to be as good as the other one. Whenever you run this Cabri Express, it just pops up for you like this. Or, let's go back. Let's do this. Express. Let's go to copy. Then I'll show you the original website. So when you get here, there's this launch Cabri Express. When you come from this launch Cabri Express, it gives you two options, Cabri Express and Cabri Express Primary. The only difference is this is a little simpler than the interface than the Cabri Express. That's for the early year kids to use that one. But I'm going to use the Cabri Express. And you can also download the OS version or Windows version to run on your computer, whichever you want to do that. But I'll run on the browser right now. When you run the software, this is the software. I mean, it's not very complex again, like the other softwares that we have. There's a calculator on the left-hand side. That's a dynamic calculator that as we can use like a regular calculator, but it also takes some variables within these software that we'll use that later. So either you can close this by clicking the X or the calculator icon in here. You can turn it on and turn it off. There is brief like help tutorial on this one. Whenever you choose any other tool, it gives you an idea what this tool is, how that tool works. As I said, this is going to be like powerful soon, but it's not as powerful as the original software yet. As you see, there are decks of tools. Whenever you are seeing, this means that there are some other tools on behind this. And then when you click that, it's going to be slow because I'm just recording this time my screen to share with you. And it just brings you all the tools within that category. The main category is the pointer, but within this one, we're going to use the hide and show and delete a lot. So we're going to come the other ones later, but these three, the first three, are the most common ones that we'll use. Each one of them has some more tools than within a category that you can see. Like, for example, the point is related to the intersection of the points, midpoint, and measurement transfer. So they have some short version of the whole instead of using the whole version here. And these are some geometrical tools that we could just see. I'm just showing you all of them. This is about the circles, conics, and related to that one. These are about the two-dimensional figures like the triangles, quadrilaterals, so you can create the equilateral triangles, squares, regular like shapes that you can use that one. And there is also which is making this software different than the other ones. Now we have the three-dimensional objects, the prisms, pyramids, or specific two-dimensional objects that we have. And there is another one at the end, the nets that we will use, like that, to open and to close a three-dimensional figure, and then to create a net of that dimensional figure. Like the other software, so we have measurement tools, and then within the measurement tools we have like regular measurements, the area measurements, the volume measurements, and some other tools like the slots and coordinates that we have within this tool. Some relationship with the tools, the lines, the object that we have on this one. For example, reflection based on a line because we're on the dimension. There is a reflection based on the points, and translating a point to another point, rotating a point, or dilation a point by a constant that you can give in here. And now, whenever I'm comparing to the Cabri 3D original software, there is no option yet for creating planes. So we could just have a plane, and then we could have a reflection based on a plane in two-dimensional. This one doesn't have it yet, but I mean, so far so good. So we can use this one freely online. Last two groups of the segments, like toolbars, as that's numbers. Remember the sliders, expression, as you see that like we have algebraic expression in here, and then evaluate is kind of using a calculator calculations. We'll come to that one later too. And another one is the axis and the grids that we'll use today. Two other useful tools is trace and locus. We'll again hopefully like use these tools together just today too. Um, this is the whole software. This is opening a new blank sheet that if you want to open that one. This is making the center view whenever you click things and I click that it brings into the like the center view. This is to save, the icon is to save whatever you have. And this is to open the documents that you saved. That's the whole document. So let's start with very simple things, very basic things first, and to get practice with that, with this one. And for example, let's get a square from the toolbar that we have, and then you can just do the same thing on the computer, so you can follow me or you can not, whatever you feel comfortable. I get a square. Whenever you get a square, it just shows a brief GIF image over here how to use this tool. To construct a square, it asks for a center and a corner. If I click again, it's going to finish the constructing this one. So I'm just going to click like this. So now I have my square. Whenever you finish with that object, it automatically goes back to the arrow button. With the arrow button, so you can move things on the screen, you can enlarge things, because this is just like, a square. It's always a square, a big square, a small square. Um, that you can move things in. Or if it shows location, oh, I can show you that. So whenever you right click on this one, it opens a very brief um, features that changing the colors of the lines or the transparency of the lines surrounding the shape that you have. Let's change to show you the color to green, for example. And you can do the same thing with the filling, and again we can do the same thing. And you can change the transparency based on what you need. You can change the line to dashed line, or just a pointed line, or the different line segments that you have. And whenever the software gets like powerful, they're gonna probably add more features. We used to have more features in this one, but this is for just decoration of this. So let's have a square. Let's try to create. Um, let's try to create a net of a cube to this one. So I need to create the same squares around this one. So what I'm going to do is I'm just going to do a reflection based on a line. So what this tool will do is it's going to take the reflection of whatever I have. I'm going to select one thing, and then the second thing it asks for me to select is the line, like which line that I will use a reflection line. I'm going to use this one. Before even I click, it shows me how the tool will just like end up. And then the second click will click me the second part of the square. And so I'm gonna use this tool again. So in order to use this tool again, as you remember that the computer just goes back to the arrow tool in here. So I need to re-choose the tool again. So if I'm going to use it multiple times, so that's like, it's kind of exhaustive, like, selecting the same tool again and again and again. Instead of that, what you can do is you can double click on this one, and the color of the tool changes, the background of the tool changes to yellowish or this color. That means that it's not going to deselect whenever I use this one, so I can use multiple times this tool. And I'm going to use this, reflect this one based on this line. I'll do one more. So I have the 4 squares of the whole cube that I have, and I'm going to use another 2. So this is a net of a cube. The good thing with this software, this is still like we see that one in 2 dimensions, but this is a 3-dimensional software. if you right click and hold, then you can change the view of the plane that you have. So still I can see that there's a plane and the net that I have I created on the plane. So you can do this one. And the original Cabri 3D, you could have multiple planes and then you could play with the planes. That was more fantastic if you compare that one. So now I want to convert this one, the net of just like a cube, into three-dimensional object, and I would like to show my student that how this opens and closes. In order to do that, I'm going to go to the three-dimensional menu bar, and I'll choose the nets. When I choose the net, again, it tells me how to use this tool. Like it just gives me an option of that. And whenever I have a flow, click it, convert that one, that net, into a three-dimensional object. As you see now, I can show you that it's in three-dimensional, in three dimension, and you can still hold the part and open and close. If you hold shift, it's open and close with degrees of like 15 degrees. Let's send this one, for example. Because I'm screen recording and I'm also like sending this to YouTube for you to watch later. And also we are on the together.com. My computer is having hard time. Now I have a cube, and then I can just like move the cube around it. Like, could you be able to run on your iPad? Does it work? Three dimensionally? Okay. I see that. There should be an option which I haven't tried on the iPad, so normally there should be. But I had a problem to do in three-dimensional using the trackpad, so maybe that's you're having the same problem. So that's is my bringing a mouse to move that. But normally, either two fingers or three fingers should do that. They say, but I couldn't do it on my trackpad on my Mac, but I'm using a mouse on this. But you can try on a computer later. Just like just help me with. I'll try later. So this is how you can create things, not just like cubes, but we could do rectangular prisms or the other types of prisms, and then we can open and close them by doing this one. So this is one example for this. So you just like practice in a couple of minutes, and I'm just gonna like open another document that I'll show it to you, like to do this today. Yes. Right click. So there's always a three-dimensional figure. So if you click this, the home button, it's just like you see like this. It's like you're holding the paper like this. What you do, right click, hold and right click, and then move it. You see the icon on that one? There's this like two rotational arrows on the screen. Whenever you see that one, that means that you can rotate within 4 dimensions. How you do it. You try on your computers, and then I'll just like walk in here within the class. If you have any questions, just speak up, and then I can come back to that one. But I'll walk within my class, and then you just try on your computer. We just tested if you are on an iPad, so two fingers make this three-dimensional move, and it worked fine, and it worked well, indeed. So, in order to do this one, you need to right click, hold it, and then just like move it around. So without releasing your right click, you can do this one. If you just like finish it, could you just thumbs up and then I could continue? Or if you need more time, thumbs down that I know that you will need some more time. Thank you, Mary. Waiting for a minute, so I only saw one thumbs up. Okay, 2 minutes, and then I'll just like continue with the next one. So you play within 2 minutes, and I'll come back. Efendim? Değiştirdin mi? Oku yakaladığın zaman değiştirdin değil mi? Biraz pratik yapmak gerekecek büyük ihtimalle. Okay. So, I'll bring another example if my computer lets me do that. Any questions on the virtual side? You send the text. If you just speak up, it will be much better because my computer is so slow right now, so it takes time to move from here to chat to see chat. Alright, let's go back here. So if you want me to show the three-dimensional, like if you see, you don't see my camera, but right click on your mouse, right click, hold it, and then move it. Right click, hold it and move it. If you're asking opening the closing the net, choose the net tool and then hold any part of the uh, this cube, and then you can close and open. If you hold shift, it makes some increments of 15 degrees, so you can have certain degrees whenever you have like this, to fully open or to fully close. And now I'll open.
Yani o açılıma tıkladığımda şey olmuyor, açılım çıkmıyor. Sadece şekilleri çıkarabiliyorum.
What's the problem again, Efra? So what do you have on your screen? Can you tell me?
İşte sadece şey var, yani şekiller var, açılımını yapamıyorum. Açılıma tıkladığımda hiçbir şey olmuyor.
Do you have the nets of a cube like this? They're connected to each other? Did you create six? You don't have to have six, but do you have the six squares like I do have?
Sesini alamıyorum.
Do you have six squares? I said, like I do have. It doesn't have to six squares, but I mean, to do this one, did you make the reflection line of this the squares side by side, and then use this tool? Let's try one more thing. That you have one square, and I'm just gonna make a reflection of this square, and I'll try with this two of them, and I'm choosing the net tool. And when I choose the net tool, you should see that change on your tool. Click that one, and then it's converted into something that you could open and close like that. So try this one, Ekra, and then that we can see if you still can do it.
Şimdi hatırladım hocam, teşekkür ederim.
Okay, no problem. So I'll open another simple application. I never thought about this is a French software. I never thought about what's Cabri in French. Is there anyone else who knows what a Cabri in French? I know that Cabri is in Spanish it's goat, and when I see the symbol, it's like I guess it's goat in French too. So this is like a gift box that.
Dondunuz ama geri geldiniz.
Okay, thank you. This is like a gift box that you might think. So we have a big square like cardboard you think, and then we cut the small parts out, and then we could just like fold them to construct a box, a toy box or whatever that box we have. So let me show you which in 3 dimension. So like having this cardboard cutting parts out, and then we could just construct a box in here. And this box is a dynamic. When I change the, the part that I cut, it's very slow. Sorry for that. There. When I change this one, another thing changed on here too, on this graphics too. Did you realize that? So let me leave one thing on screen. And now you just like observe this point. And let me show this one too. Instead of locus, we can make trace. Trace is just leaving a trace behind when a thing moves on the screen. And I will tell this computer, trace this point. Whenever I move this object, and this point will move, and that's how I designed. So the x is this distance, the blue distance, 1.9 centimeters, as you see here, 1.9 centimeters. And the y-axis is the volume of this box, which is 9.36 centimeter cubed, and it's right here. So this is the intersection of the relationship between the x and y. So when I move this point, I'll change the x, and as I change the x, the volume will change, and this point will move based on that one. So I'm slowly moving. I can. But I don't want to do. Let me refresh page. Make it slow. Let me. Whenever you're working on this one, save it because there is no undo yet within this software, which I don't like it. I'm very used to undos, which I haven't seen if there is any undo. This is the little Cabri, I guess. I'm not going to change anything. I'm just going to do the same thing. Um, I will delete the locus. Instead of locus, I will add trace. That's what I will mean. Changing this x. As I change the x, y also changes, and the point moves. As the point moves, it leaves a trace. In other words, it gives the relationship between x and y, and also it's kind of sketching a graph for us. This one. You see that graph that we had by just having the trace. So with trace in this software, it's starting an investigation between two variables that we have within a graph or on a geometrical figure, so you can do the same thing. And instead of like having a traces in the first time, which was locus, and I want to show you all the places this point as this point moves. So the traces and the locus are giving the same thing. And I move this one at just a point as I pass through those spaces. But with the locus, it's pointing all the points that it passed through within a limited region. And that the region is that point is between these on this line segment. And it's just like drawing a continuous line between zero distance and the maximum distance. It's just about 3 kind of thing, and it just shows the looks. So what I'll do is I'll show you like how to construct this simple thing And meanwhile, that I'm gonna show you like some other features of this software. So I'm just gonna start from scratch how to develop this one. Let's see if this works. Now I create the blank screen, and to do that, first of all, I assume that my cardboard is a square cardboard. So that's what I get is I get a cardboard on my screen, and I said, let's make it square. It doesn't have to be a square, but to make things simple and to show the menu bars, so I choose that to be a square, but you can do anything. So we have a cardboard, and I'm going to make a box out of it. So I need to cut same parts from each side. So that's what I need to do. And to achieve that one, I can't, I'm just thinking about it. I can't pass through the half of this line to cut it. So the math, I'll find where the tool is. I guess it's right here. Nope, it's not right there. Forget where the tool is. Here, midpoint. So what this tool does is gives us if we give 2 points. So here's the midpoint. Then I want to construct a line segment between one of the corners and the midpoint. To repeat again, this midpoint and this line segment, the help of the one of the sides is define how much I will cut on this part. So that's the reason I just selected only half of it. And again, to simulate this, I will construct a point on this line segment, and when I move this, it only here that I have my green line. So now the question is, I'm just going to cut a square part of it, and then you can discuss with your students why do I have to cut a square in order to construct a box. And the reason is obvious. Whenever I fold them up, they need to match, so they need to have the same sizes. So that's the reason I'm just like choosing a square here. So there are several ways of doing this one to find exactly the same measurement on this one. And the simplest one is to find exactly the same length of same distance between this red point and with this green point to have the same measurement in here. What's the simple tool that we can use? Hmm? Reflect on what? And if you say reflect, there are two types of reflection. Reflection based on a line and reflection based on a point. Okay, so I can do that. Reflection based on a point. Okay, which point did I need to reflect and which is my reflection point? Do you want to reflect the green point? Okay, what is my reflection point? So when I click this, um, just a second, I just choose a different order. So I'm just going to choose again. First of all, you said I need to reflect based on this point, and I want to reflect this one. So it goes to the other part, which is not exactly what I want. Is that the thing that I want? I want that line, that point on this one. Because I'm just gonna define a cutting point right here, like my mouse movement. So I need to find the same distance here. Which tool that we can use?
Yeşil noktayı kullanmayacağız mıydı?
We're gonna use the yeşil.
Köşedekini değil de ortadakini yapsın.
So you wanna reflect again? Evet.
Ben hiç yapamadım ama şey değil şu an ortadaki gibi bir de burada açı reflect derken acaba açı belirleyebiliyor muyuz yani? Keşke doğru olsaydı daha iyi olmaz mıydı?
So I mean, you tell me. I'm just applying what you tell me. So that's I'm not just being by myself. It doesn't have to be reflective point. If you have a proposal, just suggest me and tell me, then I'm just gonna try what you tell me. The
Kendim
question,
yapayım da.
okay, the question is, how can I find exactly the same distance? And if that distance needs to be constructed, so when I move this one, that point will need to move to. Which tool that you think we can use? Nope. That's a kind of reflection. So which part do you want to fold in? So what kind of a fold do you want? So if you tell me the folding line, that would be our reflection line. Then I could reflect my point on that line, so that just I need to go to the same place. Where is uh, the cut, just like a folding line or the line that you have? This one? So this one? Okay. There's a distance tool. Okay, let's have the distance tool. So distance tool is just measures a distance between 2 points. So we have to, yes, this is the distance. So you wanna use that measure to here. So there is, let's try this one. There is this tool, measurement transfer. So let's see what measurement transfer is going on here. Let's just, let me know this one. Yes, that's a brief, GIF image how these tools use. So that tells me that choose a distance and let's see on this part. You see how? Yes, it did. So I'm not sure if normally, again, in the Cabri 3D, they could reverse, but this doesn't reverse. So it takes that measurement, but it's just putting onto the wrong side. But that could work. It's measuring. You see that? Just like I'm moving slowly. You see that two fade out points on the screen? So I'm going to show the in the class. There's 2 points. So that measurement is the same 900%. So that's a tool that we can use. But again, as a lack of than this version, we can't reverse. I can't say do the other version of this one. So that's the reason I can't use. Normally I could use this tool, but just think simple. Like within two-dimensional programs, that we had a tool, compass or circle. Remember that in two-dimensional program, I told you whenever we need to measure the same distance, we mostly use, I mean we don't need to, but we mostly use circle or compass. And this one they added a nice compass for us. I took the compass. And this is like a real compass. So I put that into the one needle onto the 1 point, and then I open my compass, and then click again, then I can draw it. That's the intersection point, is where is going to be the cutting point. So it's going to be, I want to cut this part. So, which I haven't yet just like I haven't just like draw my lines here, but I know where I need to draw my lines right here. So this is which I don't need to circle anymore, which I'm gonna not leads with the same reason that within GeoGebra, I'm just gonna hide this one. So still I have that point, but it's hidden, it's on the background. So I need to construct that lines in here to cut. And to do that, I have two tools using the same idea, the perpendicular tool or the parallel tool. I like using a parallel tool. So I'm just going to have the parallel tool, and then I'll just do a parallel line to this side of the square, and that's passing through this point. And they are only just like having a parallel this length, so you could extend to have to the point, just holding that one and then having that one. So I'm going to use again the same tool. I'm just going to have a parallel line on this one if I can, this one, and I want that pass through into it. Even when you're discussing with your students, just before you click, tell them just like the parallel to this line, passing through this point. So that terminology is one terminology that we want to teach our kids. So clicking is also giving each step to this software, telling what we are doing when we are having parallels. So that's I think it's important. So you just like repeat that again and again, and then you can just extend. Now I have at least this part defined. I have this point and another point that I could use. So because I know that this is the same distance here, and because it's very slow. I'm trying to make sure that I'm having the right point. Yeah, I have the point. So now I need to find the same line in here, the same distance in here, and the same distance here. So, which I can do again the same thing, constructing um, a circle. And I can do the same circle from here, a compass, from here, here, something happened, I don't know. Here you go. You don't have to, what's going on? I don't know. Something's going on. Let me choose another thing, at least show the other ways of doing that one. Instead of compass, I could just have the circle, and then I can click the center and a radius. Then it can hear me, but it doesn't hear me. I don't know why. It's some way, somehow it's hiding. So if you have some kind of a problem that I do right now, what you do is just like save this, whatever you have, it downloads it to you. So, and then you can refresh your page. As I said, there is no undo on the software yet. So that's a big problem. It makes it hard to complete things. So that's the reason I just like save it and I reopen the same document. Probably it fixes most of my problems. So what I'll do is I reopen the untitled tree in this week. Untitled tree. And I'll try again. circle. I don't know why it does that. Let me read that one. Okay, let's fix that. So, um, there's several ways to find the same spots in here, but I'll show you one other method to use a compass to find, like to draw the same circle using the same radius of the circle to any other point. So to do that, the compass, I thought that the compass should use, for example, this length and open its leg based on that. Yes, it's this. But whenever I try to draw, no, it does. Okay. So let's try this one. If I change the side of this, that circle is also changing. So if you have a measurement, either on just like as a number, measurement number, or if you have a segment, you could use the compass tool with that one too. So you don't have to just like repeat everything. Now what we can do is we can have the intersection again. It makes it easier to intersect this circle with this one, this circle. Again, double click if you want to use multiple times, which I'm going to use multiple times. I have two of my points. I have two of my points right here. So I don't need the circles anymore, which I'm going to hide and show. Double click. I don't want to see this one. I don't want to see this one. And I don't want to see this one. So, yeah. I'm going back to my tool. Now I'm just going to do the same thing with parallels and um, to these line segments, passing through any of those points, doesn't matter which one, and extend this. And I'll need one more parallel of this line passing through this point, and then again I extend this one. Here, I'm just gonna need to cut these parts, and I need to have rectangles around this to complete the box, and I need to just like have um, a prism in here. Just so in order to have prisms, so let's first complete the um, the, um, the polygons in here. Because whenever you look at this one, how the computer understands there is one polygon and there are several lines in here. So the computer doesn't know there is a polygon in here. Even if you see that, there's a square on the center, but the computer doesn't understand. So in order to make the computer to understand, we need to draw that polygon, or in this case, they have a quadrilateral. So I'm going to have multiple times, so I'm just double clicking. So I'm starting to constructing my polygons or quadrilaterals in here. So the first one, I have the second one. I'm making it slow in order not to break it again. last two. And last one. Any question? So I'm just slowing down that you can follow up, and there is a question in here on this part, I guess. Bilgisayardan önce okusun. Çağrı, bilgisayarın yok mu? Efendim? Bozuldu mu? Ters zamanda bozulmuş. Belgin, any question? Did you fix? Okay. Okay. So, I mean, because we have two polygons in here, you see the color differences between that one. And what we can do is, again, we can change the color of the background one to, I can right click, and I'm going to change the transparency to totally transparent. So then I can have total white space in here. So now, even if I just turn this one into three-dimensional, so this one um, doesn't have any two-dimensional box in here, which I need a prism around in here, and this is my prism tool. So whenever I have the prism tool, yes. What is that question again? Mm-hmm. In two dimensions? Um, in original Cabri 3D program, yes, you can do it. You could have multiple planes, like even a plane that's an inclined, not even vertical plane, and then you could do rotation around the plane. But this one doesn't let us to do that. So this is very limited. Um, but this is free, so I'm going to show that one. And the software doesn't work on my Mac because I have updated version, so it doesn't run the original software. But next week, what I'm going to try is I'm going to check my computer PC. If it runs on my PC, I'll try to show that one on PC that you could see the original three-dimensional program, the Cabri 3D, and then you can have like those kind of things that we can discuss. But this one can't do that as far as I know, as far as I played. This is not as powerful as that one, and it can't do that. Even before you come here, I was telling that there are two reflections this program supports: the points according to points, and then according to a line. But there, yes. So the specific decision is just whenever you have a point in here, it just like goes with an object in here. If you're just selecting a point, it's take this part to the other part, and this part is to the other part. But if you're taking a line, it's looking like a mirror, like taking this one. So this side is on this side. So that's, I can show you an example for the one that you can see that. If you reflect a point on a point, it doesn't change. But if you reflect an object, it makes a difference. Yes. Let me tell you this. Just 1 second. So we're going to continue this one, but before we continue this one, let me show this one. So let's triangle for example. Charlie is asking the difference between reflecting to a point and reflection by bezel line. So I'm just going to have a point on my screen, and I'm just going to construct a line also that has through here. So I'll do both reflection. So if, let me change the colors, I hope that reflection colors will be the same. Then you can see like what I mean. Okay, this is a green, this is a red one. So I'm doing a reflection based on a line. I'm reflecting this triangle on this one. So what I say, it didn't just reflect the colors, but this green color on this reflection, this green color is this one. This red color reflected on this one. But let's change this one to, no, no. If you're doing on a line, this one is reflecting like a mirror to here. Yes. Reflection is,
Hocam
yes, Elif.
ben bir şey sorabilir miyim?
Yes.
Orta noktasını üçgenin, karenin falan buluyorsunuz ya. Ben onu nereden bulacağımızı göremedim de şu anda yapamıyorum bir
Okay.
türlü. Uzun. Bir daha gösterseniz orayı.
I'll show this one. So after this reflection, I'll show that one too. So if you're reflecting a line, it's like you're putting a mirror. So it's this vertical distances. Okay. But if you take reflection to a point, let's say that again this object, but reflecting based on this point. What it does this time, it takes this point, reflects to here. It takes that point, reflects to there. So that's just like the difference between reflection based on a point and the based on a line. And the Cabri 3, the original software, that was what I was going to tell to you, is they have the reflection based on a plane too. So you could reflect three-dimensional objects. So that's the third option, which this software doesn't have it yet. So that's the difference that I was going to tell. But this is the difference between two. Hmm? The second one, based on a point. Based on a point that's so what I'm going to do is I'm going to reflect this one based on this one. Okay. So what this is doing, let me show you in here, or let me show you with the distances. So the distances should be equal, right, with the reflection. So this point, so this distance is equal to this point distance. Oops, that should be the distance. This point to this one. Yes, that's what I'm gonna do. Like now, I'm just gonna like show you that's the difference. I'm just reflecting this object to this one. Okay. So in order to measure this one, so let's move this point further away so we can change this one. Now, this vertical distance are equal. This vertical distances, and this line is the vertical distances midpoint. So if I have a line segment or a line passing through these points, let's have a line passing that point through that point, or passing this point to, again, this one, this point to this point, First of all, these are perpendicular, and this distance equal to this distance. This distance equal to this distance. How is that just like a difference based on a line and a based on a point? Because there's one reference point and two points, and then everything is based on that one point. On the line, the reference is the line, and the line has infinitely many points. Each point is reflected to the point within that line that's perpendicular. This is the closest distance, so that's why it's different. Line, yes. Line defines for each point that's reflected is the midpoint of each reflected point.
Hocam bu iki boyutlu ya hani.
Hı
Onu
hı.
üç boyutlular için de yapabiliyor muyuz?
I tried,
Ben
but
denedim olmadı.
I tried it didn't work on this one. But normally that's why I was showing this one. In Cabri 3D, the original software, you could do with the three-dimensional objects. That's the reason I'm just gonna like try to show you on my PC if that works. I'm gonna try next week the original software that you can see the difference between this software and the other one. But again, because this is a free one, so you could just like use this tool whenever you can use. And they told me that they are going to update this like this version, and then they're not going to update the other version. So eventually, this one will be doing the same things the other one is doing. So that's the reason I wanted to keep this one on, but I'll try to show you the other one too. And if we can switch to that version, we can switch to that version. I have the license, and I think I can be able to make you to install on your computer. I'm not sure. I need to check the license, and then we can discuss that one. So, but yes, normally you can do, but this doesn't let you to do that. Thanks for the questions, and let me show you the midpoint again. So if I'm going to show the midpoint on any line, so not on this one, I'm just going to keep that one as separate. So let's say that we have a distance in here. There is a tool under the point category. There is the midpoint. Two ways that you can take a midpoint is either select the 2 points, like this point and that point, or you can select a line segment or any kind of just like line segment, which could be side of a square too. It gives you the center of that point, and you make sure that this is always the center point. Does it answer your question, Edith?
Yeah, thank you. And I found it on the sidebars too.
Okay,
thank you.
great. So now I was just like telling the prism in here that I choose the prism tool, and within the prism tool, I need two things again with the prism. I need a base and I need a height. Again, this is also by itself, as I said, like parallel to this line and testing to this one. When I just choose this tool, it asks me two things to construct the object. So that's very important thing. So that means that I take an object and I just raise that one. That just like tells me what the prism, how the prism turns. And sometimes the students can have the confusion between the prisms and the pyramids. So that's just like these features also makes them to see the definition of these the objects, geometrical objects. So now I'll choose the height. I just need this height to match with this box. And then I need to select a base, which I'm selecting this one. If I select this one, it's going slow now. So, and I click, now I have my box in here. So whenever I change this side, I know the box will change too. It's whenever I have like close this part on this one, whenever I close this one, I'm sure that this is going to cover that because this has the same height, this has the same base, so that's how I'm making sure. And there's another measurement tool which measures the volume. And I can select the three-dimensional object and it gives me the volume that's here. Oops. The last thing, let me download this one. If there's anything happens, we can go there. Okay. The other thing was a graph next to it. So to see the relationship between the um, the height and the volume, and that relationship is generally being asked, what is the highest volume, the most volume that we can get with this kind of question. So to do that, I'm just going to have this axis, and I'm just going to draw, hopefully draw. Right here. This is just an axis, which I don't have any relationship between this one. I'm not gonna try to fix this because it's so slow, so because of recordings and because of screen sharing kind of thing. So I'm not gonna fix that, but it's you can hold and you can move things and then it's easily fixed. So if you want to have the grids on this toolbar of this graphics, you can have the grid, and if you can select actually, it just like shows you the grids within that graphics area. Now, the tool that you told me, the measurement tool, I'm going to use the measurement tool to measure these distances on this graph. So the next thing is, where is my measurement tool? Here, measurement transfer. I'm going to do a measurement transfer of this distance on this graphics, actually. And I have the measurement, and it asks me where exactly the point that I want. I want the center point. As you see, this is about 1.4. And you can check always if that works. As you see, as I change, that one is changing too. The next thing that I want to measure the volume as the y-axis for this one, I'm going to do the same thing, measurement transfer of this measurement on this axis and as the origin point, which I didn't have the second point in here because this part is 1 to 4. So it's limited. So what we can do is we can resize the axis here. It's going to be much smoother on your computers. I'm not gonna challenge the computer, so I'm gonna accept as is for now. So now the next thing that I need to find the intersection point of this point and that point. That's going to be our graph. So to do that, I'm gonna do translation. I'm gonna translate I'm going to do this translation, this distance, translated on this distance, on this one. So here is that the point is the intersection of the y-axis and the x-axis. And let's try one more time. Excuse me? Yönlü. Let's try it. Normally, yes. Let's do the translation one more time. And I'm just holding my buttons. It looks like it doesn't do it. It's only do one direction. But normally it should, and we used to do it, but this doesn't let us do it. That feature probably they're gonna bring it back. And that's with the combination of the tools. So whenever you're trying to those kind of things, use Shift, Control, Command, or Alt. If the computer does it, you can do it. So the next thing is, that only next thing is, the locus of this point, or if you remember that I did, trace. So the trace isn't working good on my computer because it's slow. It only puts the dots, the points, when it's passed through that part because it's having hard time to play. But it's just you see some traces that it leaves. And then you just like have projectile. When is the maximum volume that it has? And then you can just like have a relationship between that. You can just practice with those relationships between computers. And if you don't want to just like know this one, you want to see all the points that lines that we pass through, you can construct a locus. And locus is the places that point pass through as this point moves. And you have a graph like this. And when you move this, if you can, and it just moves on that line too. That's how you can create a relationship between kind of a problem, three-dimensional problem into a relationship between graphical like this, and then you can just draw, and then you can discuss what's the highest form that this one can reach, kind of thing. So this is the program. This is the simple things that we can do, and there are many things that I wanted to do, but I mean, it's a limited version. But at least there are things that we can build on this computer. Any questions so far? Any question on the virtual side? Let me stop recording.